For centuries, we've stared into the cosmos and asked one question that echoes through all of human history: are we alone? So far, our search has been guided by a simple idea: follow the water. We've been looking for planets in the Goldilocks zone, not too hot, not too cold, where liquid water might create a cozy environment for life as we know it. Basically, we've been searching for a copy of Earth. But what if we've been looking in the wrong place? What if our whole definition of life is too narrow, too terrestrial? What if the most promising world to find aliens in our own solar system isn't warm and watery at all, but a frozen, bizarre moon of Saturn? A place where it rains gasoline, and huge lakes are filled not with water but with liquid natural gas? This is the story of a world that challenges everything we thought we knew about life itself. This is Titan. Orbiting the majestic, ringed planet Saturn, Titan is a world that feels strangely familiar. It's the only moon in our solar system with a thick, dense atmosphere, and it's the only place besides Earth that we know has stable rivers, lakes, and seas. From space, it's just a featureless orange ball totally hidden by a golden smog-like haze of nitrogen. But underneath those clouds lies a landscape that is, in some ways, shockingly recognizable. The Cassini-Huygens mission, which reached Saturn back in 2004, used radar to peer through that haze. What it found was astounding. Vast plains, towering dunes, and a complex network of rivers, lakes, and seas. Titan has a weather cycle just like Earth's water cycle. Clouds form, rain falls, rivers carve out channels and flow into massive seas. But here's the profoundly alien twist. On Titan, the temperature drops to a mind-numbing -179 degrees Celsius or -290 Fahrenheit. At that temperature, water is as hard as rock. In fact, the bedrock of Titan is water ice. The liquid that carves its rivers and fills its lakes is a mix of liquid methane and ethane. Imagine standing on the shore of a vast sea, not of water, but of liquid natural gas. The largest of these, Kraken Mare, is a sprawling sea roughly the size of Earth's Caspian Sea. Some of these lakes are surprisingly deep, plunging over 100 meters, or more than 300 feet. This isn't just a different world. It's a different reality ruled by a chemistry that seems completely hostile to life. For as long as we've searched, we've had one main rule: follow the water. Here on Earth, life is everywhere that water is. From scorching volcanic vents on the ocean floor to the frozen deserts of Antarctica. Water is the universal solvent, the stage where the chemical dance of life happens. This led scientists to define the habitable zone around a star as the spot where a planet could have liquid water. Worlds outside this zone, like the frozen moons of the outer solar system, were pretty much written off as sterile wastelands. But was that a failure of the universe to create life, or just a failure of our imagination? By focusing only on life as we know it, are we missing the chance to find life as we don't know it? That's the question Titan forces us to ask. It's a world rich in the complex organic molecules needed for life, thanks to sunlight breaking down methane in its atmosphere, creating a constant drizzle of these compounds onto the surface. It has everything except liquid water. For decades, that made it a biological dead end. But what if life found another way? What if, in the freezing hydrocarbon seas of Titan, a completely different kind of biology could take root? This is where the story gets really interesting. Scientists are now seriously considering that life's most basic processes might not need water at all. Recent NASA research has shown that in the frigid, non-polar liquid methane of Titan's lakes, something incredible could happen. Here on Earth, life started when molecules called amphiphiles, which have a water-loving head and a water-hating tail, spontaneously formed tiny bubble-like structures called vesicles. These vesicles became the first primitive cell membranes, little compartments that could trap other molecules and kickstart the engine of biology. The assumption was always that you needed water for this to happen. But new modeling suggests a similar process could happen on Titan. Methane rain splashing into the lakes could throw sea spray into the air. These droplets, coated with organic molecules from the atmosphere, could self-assemble into stable, flexible membranes as they fall back into the liquid methane. These wouldn't be the cell membranes we have, but something entirely new, able to function in an environment that would flash freeze and shatter terrestrial life. They could form tiny, self-contained protocells right in the middle of a methane lake. This is a huge deal, because it suggests the very first step toward life making a cell could happen in something other than water. The blueprint for life might be way more versatile than we ever imagined. So if the basic building blocks can form, what could a living thing on Titan actually look like? We have to throw out our Earth-based rulebook. A Titanian organism wouldn't use a phospholipid membrane like we do. Instead, scientists have proposed a wild alternative, the azotosome. These are theoretical membranes made of small organic nitrogen compounds that are known to exist on Titan. They would have the perfect mix of flexibility and stability for the cryogenic temperatures of the methane seas. But life here would be slow. Incredibly slow. The extreme cold means chemical reactions would move at a glacial pace compared to Earth. Any hypothetical microbes might use hydrogen, acetylene, and ethane as food, all available on Titan, and in a weird parallel to our own biology, they would breathe out methane gas. We're not talking about complex creatures. We're talking about microscopic organisms, moving and metabolizing at a rate that would seem almost frozen to us, with a single life cycle potentially spanning thousands or millions of years. It would be a truly alien biology, a second genesis, totally separate from life on Earth. But does this weird life have to be on the surface? What about under it? As alien as Titan's surface is, there's another, maybe even more tantalizing, environment hidden from view. Data from the Cassini probe strongly suggests that beneath Titan's thick crust of water ice, there's a massive, globe-spanning ocean of liquid water. This ocean's volume could be comparable to, or even greater than, all of Earth's oceans combined. Now, this sounds like a much more familiar place to find life. But there's a catch. While the water is there, the food might not be. Recent studies looked at how the organic stuff from Titan's surface could get down to this hidden ocean. The main way would be comet impacts melting the surface ice, creating temporary pools of liquid water that would mix with the organics and then sink through the crust because they're denser. However, the math suggests this process is incredibly slow and inefficient. While simple microbes could potentially exist in this deep ocean, perhaps surviving by fermenting the few organics that make it down, the total amount of life, the biomass, would likely be extremely small. Searching for it would be like looking for a needle in a cosmic haystack. So, while Titan offers two potential homes for life, the most revolutionary one remains on its strange cold surface. All of this speculation, all these mind-bending theories are about to be put to the test. This isn't just a thought experiment. It's the target of one of NASA's most ambitious missions ever, Dragonfly. Scheduled to launch in July 2028 and arrive at Titan in 2034, Dragonfly is unlike any probe we've ever built. It's a car-sized nuclear-powered dual quadcopter drone. Because Titan's atmosphere is so thick and its gravity is so low, flying there is much easier than on Earth. Dragonfly will be able to fly from place to place, leapfrogging across the moon's surface for several years. Its mission is to study the prebiotic chemistry of this alien world. It will land in the organic-rich dune fields, which are like a giant frozen pantry of life's ingredients. It will analyze the surface, study the atmosphere, and search for chemical biosignatures, clues that could point to past or even present-day life. Dragonfly won't be able to directly spot those tiny vesicles in the lakes, but it will map out the chemistry of this world in stunning detail, telling us just how plausible a second origin of life on Titan really is. This mission will change Titan from a mysterious orange dot into a new frontier in the search for life. We are on the verge of exploring one of the most fascinating worlds in our solar system. The questions Dragonfly will try to answer are fundamental to understanding our place in the universe. If you think the idea of methane-based life is as cool as we do and want to follow this journey of discovery, make sure you subscribe and hit that notification bell. Titan stands as a profound challenge to our Earth-centric view of biology. It's a world with a methane cycle that mirrors Earth's water cycle, complete with rivers, lakes, and seas of liquid hydrocarbons. It's a world where new research suggests the very first steps toward life could form in an environment we once thought was impossibly hostile. And it's the destination for a revolutionary flying mission that will seek answers in its alien skies. For so long we've felt a kind of cosmic loneliness, a silence from the stars. But maybe we've just been listening for a language we already know. Titan whispers of a different possibility, a different kind of biology, a life built on a foundation so strange it could rewrite our definition of life itself. What would it mean for us to find life on this frozen orange moon? What would it mean if we discovered that we aren't the only way life can be, but just one variation on a universal theme? The answers are waiting for us, out there in the cold, hazy twilight of Saturn's largest moon.